Hi all. The topic of my presentation is understanding what ROC and AUC curve means. So essentially, when we speak about ROC and AUC curve, so before we talk about ROC and AUC curve, let me tell you what is the basic metrics which the ROC curve and AUC curve uses. So friends, if you have ever heard of a confusion matrix, so this is a confusion matrix what I'm showing on my screen, which is the matrix comprising of the actual class and the predicted class. That is against the prediction or against the actual values, what does the model predicts? So as we see, there are broadly 5 different metrics which are used in the industry, which are derived out of confusion matrix. One is precision, which is of ratio of true positive to true positive plus false positive. Then there is something called as sensitivity, which is the function of true positive to true positive and false negative. There is something called as specificity, which is again function of ratio of true negative to the sum of true negative and false positive. And lastly, the negative prediction value, which is a ratio of true negative to true negative and false negative. So friends, let me elaborate and let me emphasize the importance of these matrices in the field of prediction, because normally you won't find any where accuracy being used as a standard matrix. So what is the role of threshold in model performance? How does it impact decision? I'll give an example of a model classifying a mail as spam or a non-spam. Just to give an example and set the perspective, take an example that you have set a say high threshold of 95%. In this case, the model will mark only very obvious spam emails, ensuring your important emails don't accidentally get flagged. However, this might mean some less obvious spam emails might slip through into your mailbox. On the other hand, if you set a lower threshold, say 50%, the filter will catch a broader range of spam emails. But there is also a higher chance that it may incorrectly classify a legitimate email as spam. In this scenario, the threshold determines the balance between ensuring you don't miss important emails, that is the false positives, ensuring spam doesn't clutter your main inbox, which is true positive. Adjusting this threshold affects the balance, representing the trade-off in the decision making. That is, you need to decide what threshold you want so that you neither end up with high false positives, at the same time you don't end up with high false negatives. So it's a choice what a designer has to make who's designing a model. So the most important metrics what the ROC curve and the AUC curve utilizes is true positive rate and false positive rate. So what does these metrics means? True positive rate, that is TPR, also called as recall or sensitivity. True positive rate gauges the proportion of correctly identified positive instances out of all actual positive instances. Now, what does false positive rate means? It means, or it measures the proportion of actual negatives mistakenly identified as positives. Another way to compute false positive rate is by taking 1 minus specificity, focusing on the negative class. ROC curve shows how TPR and FPR, that is true positive rate and false positive rate, change as we adjust the threshold, even though both true positive rate and false positive rate can rise or fall together. The key is how fast or slow they can change compared to each other. This difference in the rates is the trade-off we often talk about. The classifier's performance is considered optimal when it achieves a high TPR without significant increase in FPR. Hence, the top left corner of the ROC curve, which signifies a high TPR and a low FPR, represents the ideal balance or the sweet spot. ROC, which is receiver operating characteristics curve. ROC curve is a graph that shows how well a classification model distinguishes between the two classes like spam and not spam at various thresholds. It lets you visualize the model's performance at all possible thresholds, not just a single one. Now, how to create a ROC curve? ROC curve is nothing but it predicts probabilities. When you ask a classification model whether something is spam or non-spam, it doesn't simply guess. Internally, the model calculates a probability. It tests different thresholds. If the model directly classifies based on its internal score, we would have to set a threshold. For instance, you might say if the score is above zero point 0.8, call it a spam. But 0.8, the right threshold. What if 0.7 is better or 0.9? It tracks TPR and FPR, that is true positive rate and false positive rate. That is, it's about actual spam emails, how many did we correctly is called spam, and false positive rate, that is about actual non-spam emails, how many did we wrongly call spam. Then it plots for each threshold the TPR on y-axis and FPR on the x-axis. Connect the dots to form a curve. Now, once we have created ROC curve, how do we use it in our model performance measurement? Now, as we mentioned earlier, that the top left corner is the best. As you see in the graph also, the more closer your model output is as compared to that of the ideal ROC curve, the better is the model. If the curve is closer to the top left, that's great. It means that we correctly identify spam without mislabeling many genuine emails, maximum true positives and minimum false positives. About the diagonal line, if the curve is above the diagonal line from bottom left to top right, our model is better than just random guessing, because the diagonal line means TPR equal to FPR, which means it's a random guessing model. That is area under the curve. The bigger the area under the curve, closer to 1, the better is our model. Last but not the least, AUC, which stands for area under the curve. Now, I have given here two important facets of AUC as to why it is important. As I have mentioned here, it gives the comparison models. Higher the AUC, better the model, and it is effective with imbalanced datasets also. That is, in case you have one dominating class in the data, it still works. It still is a more reliable matrix than the other matrices to predict or to detect the model performance. Thank you very much.